Let's take a look at the warm-up. How can you tell if a chemical formula is ionic or molecular? Which one? Yeah. So ionic is made of ions. What else? I just gave you notes on this in the previous section. Yeah, molecular is made of nonmetals. And then what about ionic? How do you know if it's ionic? Like there's a definitive way.
Isn't it nonmetals and metal?
Close. Close. Metal. Yeah.
Positive and negative charge.
Yes, but there's something that I had you write down in the previous section that we had talked about before. It's on the first page of 12.1. Okay, yes. What else?
Freely moving.
Salts are ionic compounds.
Contain metal and ammonia.
Yeah, they absolutely contain a metal or the ammonium ion. Okay, and yes, ionic compounds conduct electricity, whereas molecular do not. Okay. And what has to be present in order for it to conduct? I think you said it.
Freely moving.
Yeah, freely moving ions. And then, what are conjugate acid-base pairs?
Two substances that provide one heat.
Yeah, conjugate acid-base pairs differ by one hydrogen ion. So give me a pair of things that differs by one hydrogen ion. Yeah, water and hydronium. Okay. Okay, let's take a look at the meaning of strong versus weak. So let's come down here. And electricity is conducted when a solution contains freely moving ions. So if you're taking a look here, I've got 1 molar acetic acid solution present. Acetic acid is a weak acid. Weak acids are partially ionized. So that means that there won't be a ton of freely moving ions in the solution. It will mostly be intact molecules like this, just floating around. And then very infrequently, and I'm just going to make it as though the solution is going all the way up here because it makes it easier for me to show you in terms of like quantity. Almost all of it will be molecules. Okay. And then you may have a hydrogen ion and the acetate ion infrequently. Okay. Now, if I'm looking at the light, will the light be bright or dim?
Dim.
Yeah, this will be a dim light. Okay, over here, I have 1 molar hydrochloric acid. Hydrochloric acid is a really strong acid. Strong acids are 100% ionized. So that means in the water, I would only have ions. So you will never have an intact molecule. Okay, and then the light bulb would be dim or bright. Okay. All right, so in order for a solution to conduct electricity, ions have to be present. The right conducts electricity better than the solution on the left, even though both acids have the same concentration. There must be more ions present in 1 molar HCl than in 1 molar acetic acid. And I think that's all we need to highlight there. Okay, let's take a look at the next page. Okay. Let's talk about the difference between strong and weak acids. Strong acids completely ionize in solution. Weak acids partially ionize in solution. So if I'm taking a look at hydrochloric acid, which is a strong acid, there are 2 ways to show how it reacts with water or how it ionizes in water, okay? The first way would just be to write a dissociation equation, okay? And that's what this is. We've seen this before. That's where you write the ions that would form on the product side, okay? The second way is to show HCl acting as a Bronsted-Lowry acid, okay? So here we have our acid, and it is giving a hydrogen to water. So that makes water a base. And then if you partner these up, HCl gets partnered up with Cl-1, and its partner on the other side would be called the conjugate base. And then if you partner up water with hydronium, its partner on the other side would be the conjugate acid, okay? And this is just showing how hydronium really forms in solution, okay, when you put water and an acid together. Okay, so now, you'll also notice that we have a 1 direction arrow. That's because when it's a strong acid, it completely ionizes in solution. It doesn't turn back around and reform those molecules, okay? So make sure you know that HCl is a strong acid. Like, that's something that you need to know. You also need to know that the other strong acids would be down here. HClO4, HI, HBr, HNO3, and H2SO4. Okay, so there are 6 strong acids that you absolutely need to know. Okay? Okay. Let's take a look at the weak acid, acetic acid, that we were shown on the first page. So, acetic acid conducts electricity poorly, and that's because there are few ions present in the solution, and most of the acetic acid molecules remain intact. So that's how we know that acetic acid is a weak acid. Okay, so how would I write this in solution? There are two ways. Notice the difference in the arrows. Okay, weak acids form an equilibrium. So that means they kind of shift back and forth between ionizing and reforming their intact molecules. So here you can see that the first equation is just showing the ions that would form. The second equation is showing you the Bronsted-Lowry acid version, okay? There are so many weak acids, there is no point in you memorizing them. So if you memorize the strong acids, you automatically know that everything else is weak. Okay, now let's talk about bases. Can I move down a little bit? Okay, so for bases, the same thing pretty much applies. So if you've got a strong bases completely ionize or completely dissociate in solution. Weak bases produce very few ions in solution. Okay, some examples of strong bases would be sodium hydroxide, potassium, calcium, and magnesium hydroxide. You should absolutely memorize these 4 strong bases, okay? You should also know that a very common weak base is ammonia. We talked about that briefly before. Ammonia is NH3. Make sure you know the name and the formula for ammonia. And then let's take a look at the next page. Let's take a look at this quick check. Explain the difference between a concentrated acid and a strong acid. Okay, give me an example of a concentrated acid. What does concentrated mean? Yeah, concentrated means it has a high molarity. Give me a really high molarity for an acid. Be higher. Okay, let's look at 10 molar hydrochloric acid. That would be a really high molarity. I've got 16 molar nitric acid. Okay, in the back. Now, let's talk about what a strong acid is. Okay, could I have a concentrated weak acid?
Yes.
Yeah. Couldn't I also have 10 molar acetic acid? Okay, so both of these would be considered concentrated acids, but HCl would be my strong acid, and then acetic acid would be the weak acid. So it's totally possible to have a concentrated weak acid, okay? Well, my